Hello, I'm Ibram Sirleaf, and this is my Physics 2211 Lab 1 presentation. Introduction. The purpose of this lab was to compare data from Tracker as well as the same data on a computational model on VPython based on the movement of an object across a table to graph position versus time. To complete this lab, we used a measuring stick to measure the movement of the object, the glue stick being used as our object. By the end of the lab, we found that the Tracker data found the velocity to be negative 0.0201 meters per second, while the VPython data showed the velocity to be negative 0.0208 meters per second. The general concepts used in this lab were the velocity update, position update, and general SI units that are commonly used in physics. Models. So, two equations we used in this lab were the velocity update and position update formulas. The velocity update is velocity final equals velocity initial plus acceleration times delta t, while position update is position final equals position initial plus velocity initial times delta t plus 1/2 a delta t squared. Experiment. For this lab, the initial conditions were that time is 0 seconds, velocity initial is 0 meters per second, and position initial is also 0 meters per second. So the steps taken during this experiment were first to place down a measuring stick. The specific one we used has centimeters as the measuring distance. Then we placed a glue stick to where its circular axis was parallel to the measuring stick. Then, while recording, we pushed the glue stick. We then put this data into Tracker and set distance points, an axis, and a total length of the movement. Then, using this data in Excel, we made a graph. Next, we found the total time and total displacement of the object's movement, as well as the displacement divided by the time. We put that data in VPython as well, and made a graph of that data in Excel as well. Here are some images of the experiment as we did it. You can see the Tracker data on the top and the VPython data, as well as the slope of each of these. And you can see a picture of how we set up the object and the rulers that we could push it. The code. So the main two things used in the code for this experiment was, first we used initial position. Although it may seem like the initial position is not 0, it's very, very close to 0, so it's basically considered 0. And then we input the velocity of the ball, and then we use like the total time of the movement, and the velocity, the ball velocity is the same since it doesn't change, it's constant velocity. And then to update the position, we did the velocity times the change in time plus the initial position, which is basically 0, but still. Discussion. So some possible errors that may have been made in this lab was that the lab did not take into account any drag or friction, which are present in reality. And so technically the velocity could not be exactly 0. The net force could not be exactly 0. The Tracker data may be inaccurate based on the placing of the location points or starting and ending time. The object may not have been pushed directly horizontally, which also may have made a difference. So in this lab, two main physics principles were studied. These are the velocity update and position update formulas, which are derived from Newton's second law, and they are stated previously. The difference between the two sets of data are likely because Tracker measures the average velocity over multiple small time frames, while VPython measures the average velocity over the whole interval. Here are the questions that we are asked about the lab. So, what if the axis were flipped in the negative x and x direction? If they were flipped, the velocity would be positive for both. It is currently negative because the glue stick was moved from right to left, which is considered negative according to Tracker. And could the forces acting on the object be added to a net force of 0? Yes, since velocity is constant, theoretically the net force must come out to be 0. Conclusion. The final findings are that the velocity of the object is about negative 0.02 meters per second. Differences in the data are likely because they measure over different intervals. Thank you.